Okay, that's enough of that. Welcome to virtual I Miss Sports Day. Because we do miss our sports, right? And our other activities that we were able to do on campus. But anyway, welcome back. We're going to do some more. Who's going to play some more? Okay, there we go. Now we're back. All right, hope you guys are having a good day. Today's lesson is much shorter. We're going to review all four methods and then talk about how to find the number of solutions without having to solve the whole problem. So first thing we've got is a recap of how we could use all four methods. And we could actually use all four methods on this problem. So I'm going to show you the different ways we could use it. And then you'll start to see why recognizing that this would work with the square root formula square root method might be a better way than using the quadratic formula for it. So square roots. Anytime there's no b value, or anytime we have the parentheses squared, that's when we're going to look to use square root method. We want to get the x squared alone, so I'm going to add 25 to both sides. X squared equals 25. Take the square root. X equals, when we take the square root while we're solving, we make sure we put plus minus, and then square root of 25 is 5. So our two solutions are positive 5 and negative 5. This same problem is also factorable. In fact, it's one of our shortcuts. It's the difference of two squares. So if we use the box, let's go ahead and do a box. We haven't done those in a couple days. I'm going to put 0x in the middle because it didn't have a middle term. And then I'm going to factor using the box. First term, first box. Last term, last box. We're going to add to 0. And then we're going to multiply to this diagonal, negative 25x squared. So multiplies to negative 25, adds to 0. That's going to be a negative 5x and a positive 5x. Take out our common factor, which is x. This also has to be x, minus 5 and plus 5. So our factors are x plus 5 and x minus 5, and then we set it equal to 0. Take each factor, set it equal to 0. So x plus 5 equals 0. Subtract 5, x equals negative 5. Take my second factor, x minus 5, set that equal to 0. Add 5, and voila, x equals 5. So we got negative 5 and positive 5. Hey look, when we did the square root method, positive 5 and negative 5. So it doesn't matter which method, we'll always get the same answer for the same problem. But again, if you recognize that you could use the square root method, that's going to be a little bit shorter than factoring. We could also do this by completing the square. So to complete the square on this one, we're going to add our c value to the other side, which gives us x squared plus 0x plus our new c value equals 25. And this is kind of weird, right? I'm going to plug in x squared. I'm going to split 0 in half. Okay, so that's just 0 and 0, which means this is x plus 0 plus 0. So 0 times 0 is 0. So what am I adding to both sides? That's right, I'm adding a 0. So I know that this factors to x plus 0 squared, and then this side would be 25. Hopefully you've realized that x plus 0 is just x. So I can really write this as x squared equals 25, and now we're back to the same problem we did over here. Take the square root of both sides. X equals plus or minus 5. So again, square root method, factoring method, complete the square method, all three methods we got positive or negative 5. So when we use the quadratic formula, what should we get? That's right, we should get positive and negative 5. Let's check it out. our A value is 1, B is 0, C is negative 25. Plug those into the quadratic formula. X equals negative 0 plus or minus the square root of 0 squared minus 4 times 1 times negative 25, whoo, squeezing that in there, over 2a. X equals negative 0, which there isn't anything like that, so I'm just put 0, plus or minus the square root of 0 squared, which is 0, minus, and then I have a negative, so plus 4 times 1 times 25 is 100, all over 2. X equals 0 plus or minus the square root of 100 over 2. X equals 0 plus or minus the square root of 100, which is 10 over 2. And then I can do 0 plus 10, which is 10. 10 divided by 2 is 5. And then I can do 0 minus 10, which is negative 10, divided by 2, which is negative 5. So this is an example of a problem where we could use all 4 methods and still get the correct answer. But which one was probably the easiest one for that problem? Probably the square root method, right? So anyway, just wanted to review each of those 4 methods. But what we're going to do the rest of today is just talk about how we can quickly identify the number of solutions. So this problem, when we look back, it had 2 solutions, right? We had a positive 5 and a negative 5. 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 That's 2 solutions. So is there a way to find out the number of solutions without actually having to solve? And there is. So if we look at these 3 problems, this is the quadratic formula, but kind of simplified halfway through the problem. If we have square root of 16, that's a positive number, right? How many solutions will we get? We'll get 2, because when I simplify that square root, I get plus or minus 4. So if I add 4 and subtract 4, that's going to give me 2 different answers. So we're going to end up getting 2 solutions. But what if the square root is a 0? Well, that would give us 8 plus or minus 0 over 2. 8 plus 0 divided by 2 is 4. But what's 8 minus 0 divided by 2? It's also 4. So you actually end up getting the same answer twice, because even though it says plus minus, we're adding and we're subtracting nothing. So the problem is really just 8 over 2 for the solution. So your answer would be 4, right? So that is 1 solution. And then this last example, we have a negative inside the square root. Well, what happens when we take the square root of a negative number? We get no real solutions. So no real solutions. So anytime we solve a quadratic equation, it's possible to get 2 solutions, 1 solution, or no real solutions, which we're also going to say at this point, that also means you have 2 imaginary solutions, but we're not going to find those yet. All right. So the discriminant, that's a vocabulary word we're going to use a pretty decent amount of the time. So discriminant is a word you'll want to remember, and when I show you what the discriminant is, hopefully we can memorize that. So at this point, have we identified which part of the quadratic formula lets us know how many solutions there are? So hopefully at this point we've recognized that when we write out our quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. The part that helped us determine the number of solutions is the square root, right? If I go back, if our square root is positive, we get 2 solutions. If our square root is a 0, we just get 1 solution. And if our square root is negative, we get no real solutions. So it doesn't matter what else is going on in the problem. If we can look in the square root, we can automatically tell how many solutions the problem will have. So the part that's inside the square root is the b squared minus 4ac. So this part right here is what will determine the number of solutions. So that is called your discriminant. Your discriminant is b squared minus 4ac. If that is positive, that means your square root will be positive. So even though the discriminant, technically we don't put the square root on it, I usually like to just show it, just so people remember, oh yeah, it's the part inside the square root. But we know that if this is positive, 2 solutions. If it's 0, you get 1 solution. And if it's negative, you will get no real solutions. So in these 3 examples, it asks how many solutions will each of the following equations have? So I could go through and I could try to solve the problem and do all the work and figure out, oh, yep, it has 2 solutions, I found them, or, oh, this one only has 1 solution. Or I can simply plug in b squared minus 4ac. So I'm going to go through, I know my a is 1, my b is negative 3, and my c is 5. If I plug those numbers into my discriminant, so b squared, negative 3 squared, minus 4 times a is 1, times c, then I can simplify this. Negative 3 times negative 3 is 9, minus 4 times 1 times 5, 20, and that will give me a negative 11. So I know that if I were doing the quadratic formula in this problem, this part of my formula would give me a negative 11, which means in my formula I would have square root of negative 11. Well, if we have a square root of a negative, how many solutions do we get? That's right, 0 real solutions. We're going to call this no real solution. It will have 2 imaginary solutions, but no real solutions. All right, next example. Our a value is 3, b is 6, c is 2. You'll have a Khan Academy on this. So when you're doing the discriminant Khan Academy, you'll know, oh yeah, that's where I just plug into b squared minus 4ac. But anyway, so b squared is going to be 6 squared minus 4 times a times c. So I get 36 minus 4 times 3 is 12. 12 times 2 is 24. 36 minus 24 is 12. So I know that if I were using the quadratic formula, I would get the square root of 12. Well, since that's a positive, that means when we're solving this problem, we're going to have something plus the square root of 12 and something minus the square root of 12, which gives me 2 different answers. So this will have 2 solutions. And then the last one, to determine the number of solutions, again, I'm going to list out my a, my b, and my c. I'm going to plug them into my discriminant, b squared minus 4 times a times c, which is 9, minus 4 times 2 is 8. 8 times 10 is 80. And 9 minus 80 is a negative 71. And again, if I get square root of a negative, that means I will have no real solutions, or 2 imaginary solutions. I'm going to throw one more problem up here just so we can see what it'll look like if there is 1 solution. So let's go x squared plus 8x plus 16. Okay, so if I asked you for the number of solutions, we would use our discriminant, right? So discriminant, which is b squared minus 4ac. We're going to identify that our a is 1, our b is 8, and our c is 16. So b squared, 8 squared, minus 4 times a times c. So again, we're plugging our a, b, and c into the discriminant. which is really the square root, right? The square root part of our quadratic formula, which gives me 64 minus 64, which means we really get the square root of 0, and the square root of 0 is 0. So if we were solving this problem, we'd have some number in front, plus and minus 0. But if we add 0 and subtract 0, are we really changing the problem at all? No. So we really just have whatever term was in front divided by the 2a. So we'd end up with one solution. So again, if your discriminant is 0, you get one solution. If your discriminant is negative, you get no solutions, or no real solutions, but 2 imaginary. And if your discriminant is positive, you will always get 2 solutions. So let's go ahead and end with a quick checkpoint. Or not quite end, we're going to do a couple more things. But I'm actually going to change this problem just a little bit, because we've done a lot that are equal, or that are no solution. So let's change it to x squared plus 2x minus 5 equals 0. And go ahead and tell me how many solutions this problem will have. All right, let's see how you did. A is 1, B is 2, C is negative 5. We're going to plug that into our discriminant, right? So we're going to plug it into b squared minus 4ac. So we're going to do 2 squared minus 4 times 1 times c, which gives us 2 squared is 4, minus, but then a negative, so minus and negative makes plus 4 times 1 times 5, and we end up getting a discriminant of positive 24. So if our discriminant is positive, that means we're going to add and subtract that number when we're completing the problem, so we will get 2 different solutions. All right, this one would have given you no solution again. We already did 2 of those, so I changed it. All right, now we're to the last problem of the day. Told you it would be much shorter today. We have our exit problem, just another chance for you to see how you're doing with the quadratic formula. So go ahead and take out your piece of scratch paper and go ahead and try this problem. Let's see what you get. And we're back. Wow, it's amazing how we're back again. All right, quadratic formula, we must equal 0. Good. We must then identify our a, b, and c. So a is 8, b is negative 5, c is negative 1. Then we're going to plug those into the quadratic formula. X equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a, which was 8. All right, continue simplifying. X equals 2 negatives make a positive, so positive 5, plus or minus the square root of negative 5 squared. Negative 5 times negative 5 is positive 25. Minus, but then we have another negative. 2 negatives make a positive. 4 times 8 is 32. All over 16. X equals 5 plus or minus the square root of 57 over 16. And then if I try to go simplify the square root of 57, the only factors of 57 are 3 and 19, which there is no buddy or no partner to leave the square root, so this will stay plus or minus square root 57, which means we have solved it. Hope you did all right. Hope you guys are doing okay with this. Continue to do your Khan Academy, your Illuminate. Make sure you're meeting with your teacher on Zoom. If you have any questions, let us know. And we'll see you again soon. Go Titans.